Hello students, in this video we will start chapter number 9th of NCERT, that is sequences and series. Now from in exercise 9.1 from question number 1 to 6th, the nth term of the sequence is given to us and we have to find out its 5 terms. Now in question 5th, an, that is nth term, is given by minus 1 raised to power n minus 1 into 5 raised to power n plus 1. Now its 5 term will be determined by putting the value of n as 1, 2, 3 up to 5. Now first term will be a1 and that will be minus 1 raised to power 1 minus 1 into 5 raised to power 1 plus 1. Now in place of n we will take 1 here and that will be equal to 25. Now second term a2 will be given by minus 1 raised to power 2 minus 1 into 5 raised to power 2 plus 1 and that will be equal to minus 125. Similarly, third, fourth and fifth term can be obtained. Now fifth term will be obtained by taking n is equal to 5 and that will be minus 1 raised to power 5 minus 1 into 5 raised to power 5 plus 1 and that will give us answer as 15625. Similarly, we can do other questions of this exercise. Now in question number 14th, the Fibonacci sequence is defined by 1 equal to a1 equal to a2, that is value of a1 and a2, that is first and second term, is 1, and an, that is nth term, is given by an minus 1 plus a n minus 2, where n is greater than 2. Now we have to find an plus 1 upon an for n equal to 1, 2, 3, 4 and 5. Now for n equal to 5, now this an plus 1 will be a5 plus 1, that is a6 upon a5. That means the highest term that we have to obtain is equal to a6 from the Fibonacci series. Now here a1 is equal to a2, that is equal to 1 given to us, and an is equal to an minus 1 plus an minus 2, where n is greater than 2. Now third term of the sequence, that is a3, will be equal to a3 minus 1 plus a3 minus 2. Now that will be equal to a2 plus a1. As we know that a1 and a2 are equal to 1, so that will be equal to 1 plus 1 equal to 2. Similarly, a4 will be equal to, now in place of n we will take 4, the a4 will be equal to a4 minus 1 plus a4 plus 2 and that will be equal to a3 plus a2. As we know, a3 was 2 and a2 was equal to 1, so the value of a4 will be equal to 3. Similarly, we can obtain a5, or we can find a5 and a6, and a5 is equal to 5 and a6 equal to 8. Now we have to find the value of n plus 1 upon an for n equal to 1, 2, 3, 4 and 5. Now for n equal to 1, the an plus 1 upon an will be equal to a1 plus 1 upon a1 and that will be a2 upon a1. As we already have obtained the value of a1 and a2 and is equal to 1, so that will be equal to 1 by 1 and that will be equal to 1. Similarly, we can find the value of an plus 1 upon an for n equal to 2, n equal to 3, n equal to 4 and n equal to 5. Now for n equal to 5, n plus 1 upon an will be equal to n is 5, 5 plus 1 upon a5 and that will be equal to a6 upon a5. Now a6 was equal to 8 that we have obtained from the Fibonacci series upon a5 and that was equal to 5. So the value of an plus 1 upon an for n equal to 5 will be equal to 8 upon 5. Now come to exercise 9.2. In exercise 9.2, we will study about arithmetic progression, that is AP. Now a sequence a1, a2, a3 and so on up to an, and there can be other terms also, is called AP if an plus 1 is equal to an plus D, where n belongs to natural number. Now where A1 is called the first term of the AP and the constant term D is called the common difference of the AP. Now nth term of AP is AN equal to A plus n minus 1D, and sum of n terms of the AP is given by Sn, and that equal to n upon 2 into 2A plus n minus 1D, and if last term L is known to us, then Sn is equal to n upon 2 into A plus L. Now the arithmetic mean, that is A denoted by A, of any two numbers A and B is given by A plus B upon 2. That means the sequence A, arithmetic mean, and B are in AP. Now in question number 3rd of exercise 9.2, in an AP, the first term is 2 and sum of the first 5 terms is 1/4 of the next 5 terms, and we have to show that 20th term of the AP is minus 112. Now here the first term of AP is given to us, and that is equal to 2. Now it is also given to us that sum of the first 5 terms is equal to 1/4 of the sum of the next 5 terms. That means S5 is equal to 1/4 of S10 minus S5. Now sum of the first 5 terms means A1 plus A2 plus A3 plus A5, and sum of the next 5 terms will be A6 plus A7 plus A8 plus A9 and plus A10. Now that means if we subtract the sum of first 5 terms from the sum of first 10 terms, then that will give us the sum of the terms from 6 term to the 10 term. So we can say that the sum of first 5 terms will be S5, and the sum of the next 5 terms from 6 term to the 10 term will be equal to S10 minus S5, and that will be give us 4 into S5 equal to S10 minus S5. Now that means 5S5 will be equal to S10. Now as we know that Sn is given by n upon 2, 2a plus n minus 1 d, so S5 will be equal to 5 upon 2 into 2a plus 5 minus 1 d, and S10 will be equal to 10 upon 2 into 2a plus 10 minus 1 d. Now that will be equal to 25 upon 2 into 2 into a, and a was equal to 2, that is first term, plus 5 minus 1, that is 4d, equal to 5 into 2 into first term, that is again 2 here, and plus 9d. And this on simplifying will give us 20 plus 20d is equal to 8 plus 18d, and that will give us the value of d as minus 6. Now we have to prove that 20th term of the AP is minus 112. So we can say the 20th term of AP, that is A20, will be equal to A plus 20 minus 1, as AN is equal to A plus N minus 1D. So A20 will be equal to A plus 20 minus 1D, and that can be written as A plus 19D. The value of A was 2 and D we have just obtained as minus 6. So after putting the values of A and D, we are getting A20 as minus 112, which we had to prove. Now in question number 5th, if the pth term of the AP is 1 upon Q and the qth term is 1 upon P, we have to prove that the sum of first PQ terms is 1 upon 2 into PQ plus 1, where P is not equal to Q. Suppose the first term of the AP is A and the common difference is d. So pth term of AP is given to 1 upon q. That means that AP will be equal to 1 upon q. Now AP will be A plus P minus 1D, and that is equal to 1 upon q given to us. Now qth term of AP is given to us as 1 upon q. That means AQ will be 1 upon P. Now P term is 1 upon P, and that will be A plus Q minus 1D, that is equal to 1 upon P. Now on subtracting equation second from equation first, A will be eliminated, and that will give us P minus 1 minus Q plus 1D equal to 1 upon Q minus 1 upon P, which on solving will give us the value of D as 1 upon PQ. Now on putting the value of D in equation first, A plus P minus 1 into 1 upon PQ will be 1 upon Q. That means A plus P into 1 upon PQ, that will be 1 upon Q, minus 1 upon PQ will be equal to 1 upon Q, and that will give us the value of A as 1 upon PQ. Now that means the sum of first PQ terms of the AP will be given by SPQ, and that will be equal to PQ upon 2 into 2A plus PQ minus 1 by the formula of Sn, and that is n upon 2, 2A plus n minus 1D. As we know, the value of A was 1 upon PQ, and value of D is also 1 upon PQ. So after putting the value of A and D, SPQ will be equal to PQ upon 2 into 1 upon PQ plus PQ minus 1 into 1 upon PQ, which will be equal to PQ upon 2 into 2 upon PQ plus PQ into 1 upon PQ will be equal to 1, and minus 1 into 1 upon PQ will be minus 1 upon PQ. Now after taking PQ as LCM, we will get SPQ as PQ upon 2 into 2 plus PQ minus 1 upon PQ, which on solving will give us the value of SPQ as 1 upon 2 PQ plus 1, which we had to prove. Now in question number 8, if the sum of n terms of the AP is given by Pn plus Qn square, where P and Q are constants, then we had to find out the common difference of the AP. Now here sum of the n terms of AP is given to us, that is Pn plus Qn square. Now that means Sn is equal to Pn plus Qn square. Now first term of the AP, that is A1, will be equal to S1, and S1 will be equal to P into 1 plus Q into 1 square, and that is P plus Q. As we know that An is equal to Sn minus Sn minus 1, so A2 will be equal to S2 minus S1. Now here S2 will be given by putting the n is equal to 2. Now that means S2 will be P into 2 plus Q into 2 square, and that will be equal to 2P plus 4Q, and therefore second term A2 will be equal to S2 minus S1, and that will be 2P plus 4Q. That was S2 minus S1, and S1 was P plus Q, and this will give us A2 as P plus 3Q. Now here we have to find the common difference of the AP, and then as we know, the common difference of AP D will be given by A2 minus A1, and that will be P plus 3Q minus A1. A1 was P plus Q, and that will be equal to 2Q. Now in question number 9th, we have the sum of the n terms of two arithmetic progressions are in the ratio 5n plus 4 is to 9n plus 6. We have to find out the ratio of their 18th term. Let A1 and A2 and D1 and D2 be the first terms and the common difference of the first and the second AP respectively. Then And here it is given to us that sum of the n terms of first AP upon sum of the n terms of the second AP is equal to 5n plus 4 upon 9n plus 6. Now as we know that Sn is equal to n by 2, 2 into a, that is first term, plus n minus 1 d. So here the sum of the n terms of the first AP will be n by 2 into 2a1 plus n minus 1 d2, and sum of the n terms of the second AP will be n upon 2 into 2a2 plus n minus 1 into d2, as first term of the first AP is a1, common difference is d1, and the first term and common difference of the second AP are a2 and d2, and that is equal to 5n plus 4 upon 9n plus 6, which is given to us. Now this will give us 2a1 plus n minus 1 d1 upon 2a2 plus n minus 1 d2, and that will be equal to 5n plus 4 upon 9n plus 6. Now I have taken it as equation first. Now we have to find out the ratio of the 18th term of the first AP to the 18th term of the second AP. 18th term of the first AP will be equal to A1 plus 17D1, as AN is equal to A plus N minus 1D. So A18 will be equal to A plus 18 minus 1, and that is 17 D1. Now, and second 18th term of second AP will be A2 plus 17 D2. Now here on comparing this with the left hand side of the first equation, in the left hand side of the first equation there is 2a1 and here it is a1. So on multiplying this equation by our ratio of 18th terms by 2, we will get 2a1 plus 34d1 upon 2a2 plus 34d2. Now on comparing the left hand sides, n minus 1 will be equal to 34, and that means that n will be equal to 35. So on putting the value of n equal to 35 in equation first, we will get the right hand side as 5 into 35 plus 4 upon 9 into 35 plus 6. Now as we know that 2a1 plus 34d1 upon 2a2 plus 34d2 will be equal to a1 plus 17d1 upon a2 plus 17d2, and that will be equal to, now right hand side will be equal to 5 into 35 plus 4 upon 9 into 35 plus 6, and that will be equal to 179 upon 321. So we can say that the ratio of the 18th term of first AP to the 18th term of second AP will be equal to 179 upon 321. In question number 10, if the sum of first P terms of the AP is equal to the sum of first Q terms, then find the sum of the first P plus Q terms. Now here let the first term of the AP be A and common difference be D. It is given to us that sum of the first P terms is equal to sum of the first Q terms of the AP. That means P upon 2 into 2A plus P minus 1D will be equal to Q upon 2 into 2A plus Q minus 1D. Now by the formula of Sn is equal to N upon 2 into 2A plus N minus 1D. Now that means that this will be equal to 2AP plus P into P minus 1 into D equal to 2AQ plus Q into Q minus 1 D. Now this will give us 2AP minus 2AQ equal to Q into Q minus 1D minus P into P minus 1D. Now taking 2A as common from the left hand side, the left hand side will be 2A into P minus Q, and the right hand side can be written as Q square minus Q minus P square plus P into d on taking d as common, and this will give us 2a into p minus q equal to q square minus p square plus p minus q into d. Now q square minus p square can be written as q plus p into q minus p. Now again here, on taking minus 1 common from q minus p, now this right hand side will be equal to minus p minus q into p plus q plus p minus q into d, and this will give us p minus q into 1 minus p minus q into d. Now on eliminating p minus q from both sides, we will get 2a is equal to 1 minus p minus q into d. That means a will be equal to 1 minus p minus q upon 2 into d. Now we have to find out the sum of first p plus q terms. That means sp plus q, and that will be equal to p plus q upon 2 into 2a plus p plus q minus 1 into d. Now that will give us p plus q upon 2 into, now 2a, as we know that 2a was equal to 1 minus p minus q into d, so that will be equal to 1 minus p minus q into d plus p minus q minus 1 into d, and that will give us p plus q upon 2 into 0 into d, and that will be equal to 0. The sum of first p plus q terms of the AP will be equal to 0. Now in 11th question, sum of the first p, q and r term of the AP are given to us as a, b and c respectively. Now we have to prove that a upon p into q minus r plus b upon q into r minus p plus c upon r into p minus q will be equal to 0. Now let the first term of AP be a and common difference be d. Here the sum of first p terms is given to us as a, that is p minus 2 into 2a plus p minus 1d will be equal to a. On dividing both sides by p, we will get a upon p equal to 1 upon 2 into 2a plus p minus 1d. This is equation first. Now sum of first q terms is given to us as d, that means q upon 2 into 2a plus q minus 1d will be equal to b. Now on dividing both sides by q, b upon q will be equal to 1 by 2 into 2a plus q minus 1d, and this is equation second. Sum of the first r terms is equal to c, that means r upon 2 into 2a plus r minus 1d will be equal to c, or we can say c upon r will be equal to 1 upon 2 into 2a plus r minus 1d, and that we have taken as equation third. Now we have to find out the value of a upon p into q minus r plus b upon q into r minus p plus c upon r into p minus q. Now on putting the value of a upon p, b upon q and c upon r from equation first and second, that will be equal to 1 upon 2 into 2a plus p minus 1d into q minus r plus 1 upon 2 into 2a plus q minus 1d equal into r minus p plus c a 1 upon 2 into 2a plus r minus 1d into p minus q. Now on writing the coefficients of a and coefficients of d together, this will equal to 1 upon 2 into 2a into q minus r, or we can say 2 into q minus r plus 2 into r minus p and plus 2 into p minus q into a plus, now here coefficients of d are p minus 1 into q minus r plus q minus 1 into r minus p plus r minus 1 into p minus q into d, and this will be equal to 1 upon 2 into 2q minus 2r plus 2r minus 2p plus 2p minus 2q into a plus pq minus pr minus q plus r plus qr minus pq plus minus r plus p and plus rp minus qr minus p plus q into t, and this will be equal to 1 upon 2 into 0 into a plus 0 into d, and that will be equal to 0. Now in question number 12, the ratio of the sum of m and n terms of the AP is m square ratio n square. We have to prove that the ratio of mth and nth term is 2m minus 1 ratio 2n minus 1. Now let the first term of the AP be a and common difference be d. Now sum of the m terms ratio sum of the n terms is equal to m square ratio n square, or we can say sm upon sn is equal to m square plus n upon n square is given to us. That means m upon 2 into 2a plus m minus 1d upon n upon 2 into 2a plus n minus 1d will be equal to m square upon n square. Now this m will eliminate from both sides. 1 upon 2 will cancel out, and that will give us 2a plus m minus 1d upon 2a plus n minus 1d equal to m by n. Now this will be equal to 2an plus n into m minus 1d equal to 2am plus m into m minus n minus 1d, and this will give us 2an minus 2am equal to m n minus 1 minus n m minus 1 into d, which on solving will give us 2a equal to d. Now we have to find out the ratio of mth and nth term, that is am upon an will be equal to a plus m minus 1d upon a plus n minus 1d. Now on putting the value of d as 2a from equation first, this will be equal to a plus m minus 1 into 2a upon a plus n minus 1 into 2a, which will be equal to 2am minus a upon 2an minus a. Now this will give us, or that will be equal to 2m minus 1 upon 2n minus 1. Thus we can say that am ratio an will be equal to 2m minus 1 ratio 2n minus 1. Now in question number 13, if the sum of n terms of AP is 3n square 5n and its mth term is 164, then we have to find the value of m. Sum of n terms of the AP, that is Sn, is given to us as 3n square plus 5n, and mth term of AP, that is Am, is equal to 164. As we know that An equal to Sn minus Sn minus 1, so Am will be equal to Sm minus Sm minus 1, and that is equal to 164. Now Sm will be equal to 3m square plus 5m, and Sm minus 1 will be equal to 3m minus 1 square plus 5 into m minus 1, and that is equal to 164, and difference of these two is equal to 164. Now this will give us on solving m as 27. Now in question number 15, if a raised to power n plus b raised to power n upon a raised to power n minus 1 plus b raised to power n minus 1 is the am, that arithmetic mean between a and b, then find the value of n. Here a raised to power n plus b raised to power n upon a raised to power n minus 1 plus b raised to power n minus 1 is the arithmetic mean between a and b. That means this will be equal to a plus b upon 2. Now this will give us 2 on cross multiplication, 2a raised to power n plus 2b raised to power n equal to a raised to power n plus a b raised to power n minus 1 plus a raised to power n minus 1 into b plus b raised to power n. Now that will be a raised to power n plus b raised to power n equal to a b raised to power n minus 1 plus a raised to power n minus 1 into b, which will give us a raised to power n minus a raised to power n minus 1 into b equal to a b raised to power n minus 1 minus a raised to power b raised to power n. And on taking a minus b as common from both the ends, we will get a raised to power n minus 1 into a minus b plus b raised to power n minus 1 into a minus b, which on solving will give us a raised to power n minus 1 equal to b raised to power n minus 1. So we can say that a upon b raised to power n minus 1 will be equal to 1. So this can be written as a upon b raised to power n minus 1 equal to a upon b raised to power 0, as a upon b raised to power 0 will be equal to 1. Here base are same, so n minus 1 will be equal to 0. That means n will be equal to 1. Now in question number 16th, between 1 and 31, m numbers have been inserted in such a way that the resulting sequence is in AP. Now we have to find out the ratio of 7th and ratio of 7th and m minus 1th term is given to us as 5:9, and we have to find out the value of m. Let m numbers inserted between 1 and 31 be a1, a2, a3 up to am, such that 1, a1, a2, a3 up to am, 31 are in AP. Now here the first term a1 is 1 and the last term, that is m plus 2th term. Now m numbers are inserted between two terms 1 and 31. So total number of terms in AP will be m plus 2. So m plus 2th term of the AP is equal to 31. That is am plus 2 will be equal to 31, as an is equal to a plus n minus 1d. So am plus 2 will be equal to a plus m plus 2 minus 1d, and that is equal to 31. Now a, that is first term, is given to us 1. So this will give us 1 plus m minus 1d is equal to 31, which will give us d as 30 upon m plus 1. Now ratio of the 7th number and m minus 1th number inserted is 5 upon 9 or 5:9. That means a7 upon am minus 1 will be equal to 5 upon 9, as now the 7th number inserted will be 8th term of the AP, and the m minus 1th number inserted will be mth term of the AP. That we can say that a8 upon am is equal to 5 upon 9. Now a8 or 8th term of AP will be given by a plus 7d, and mth term of AP will be equal to a plus m minus 1d, and that is equal to 5 upon 9. Now as first term of the AP, that is a, is 1. So on putting the value of a as 1, we will get 1 plus 7d upon 1 plus m minus 1d equal to 5 upon 9. Now d, we have already obtained the value of d as 30 upon m plus 1. So on putting the value of d, we will get this as 1 plus 7 into 30 upon m plus 1 whole upon 1 plus m minus 1 into 30 upon m plus 1 equal to 5 by 9, which on solving will give us the value of m, and that is equal to 14. In question number 18th, the difference between two consecutive interior angles of a polygon is 5 degree, and if the smallest angle is 120 degree, then we have to find out the sides of the polygon. Now suppose the number of sides in a polygon be n, Difference between two consecutive angles is 5 and the measure of the smallest angle is 120. As we know that the sum of interior angles of a polygon are given by 2n minus 4 into 90, where n is the number of sides. So here Sn will be equal to 2n minus 4 into 90. Now Sn is given by n upon 2 into 2a plus n minus 1d, and that is equal to 2n minus 4 into 90. Now here A, that is the smallest angle, is 120 degree, and D, that is difference between two consecutive angles, is 5 degree. So that will give us n upon 2 into 120 plus n minus 1 into 5 equal to 2n minus 4 into 90, which on solving will give us the value of n as 16 or 9. Thus, we can say that the number of sides in a polygon will be equal to 9. Thank you.